So hi, so today I want us to look something to do with moment over force. So this is physics. So moment over force. So let's take for instance, you have a hurdle here. Let's say we have a door here. This is a door, of course. The handle of the door is at the outside edge. Let's take for instance, this is the frame here. We have this, so of course the edge, the handle here, it's here at the edge here, of course. So it's supposed to be here. So from there, why it's supposed to be outside of the edge, so it opens and closes easily. A much larger force would be needed if the handle were near the hinges. Similarly, it is easier to loosen a nut with a long spanner than with a short one. The turning effect. So I want us to give some definitions. Turning effect. Can bring this. We have turning effect. We have turning effect. So what is turning effect, or simply known as moment over force? This is a moment over force. So what's this? What do we mean? So this is simply a measure of a turning effect over force. So this is a measure of a turning effect over force. Measure of a turning effect over force. Over force. So turning effect or moment over a force is simply measure of turning effect over force. So it depends on both the size and the force. Of course, the turning moment or the turning effect or moment of force, this is a vector. It depends on both. There is we have said it depends on both size and force. So this is size, and it also depends on this two is size or magnitude. So that's what we mean. The two of them is dependent on these two here. So from there we can also say that and it depends on both the size of the force and how far it is applied from the pivot to fulcrum. Also we can say this is how far it is applied. How far it is applied. We are trying to mean that how far it's applied from the pivot or fulcrum. That is applied from pivot or fulcrum. So what do we mean this? It is measured by multiplying the force by the perpendicular distance. Also a point to note is measured by multiplying the force and perpendicular distance. So simply here we are trying to mean that moment of force, we can write it as a formula. So here we have moment of force is equals to force multiplied by the perpendicular distance. This is force multiplied by the perpendicular distance. Of course, the perpendicular distance, this is of the line of action of the force from fulcrum. So we can say that we can try to draw something here. Maybe we have, this is a hinges. This is a gate. We have a gate here. So we can call this as a hinges. So this is hinges. sorry for that. This is hinges. From we can see this is 3 meters, of course. This is 3 meters. Sorry for that. This machine is like so we can say this is 3 meters, and this is a hinges, of course. So 3 meters, and then here there is a gate now. So the gate is here, of course, and we have, so you can see from the hinges here, we have, when we divide this by 2, we can have something like this. We have we can have by half here, so the distance from here is 1.5 meters to here, and from here to here is 1.5 meters. This one like that. So you can see now this is more of a balancing beam. So this was just generally to try to explain to you, so we can clean it and have a look of one example on how we can work it out. So we can look like there's something called as law of moments. So the law of moments means that the sum of the clockwise moment, okay, we can state it directly. It states that when a body is in equilibrium, is in equilibrium or in balance, the sum of the clockwise moment, the sum of the clockwise moment of the clockwise moments about the point is equal. This is about the point is equal to the sum of the anticlockwise moment of the anticlockwise moment at the same point. Because we said at the point, now here we are supposed to conclude about the same point. So when a body is in equilibrium, the sum of the clockwise moment about a point is equal to the sum of the anticlockwise moment about the same point. We can say this is remember the formula of finding the moment. We have F1d1 equals to F2d2. This is simplified law of momentum. This is law of momentum. So we can look example here and see how we are supposed to work on an example on. So an example goes like this. So we are told that in the figure below, balances the shunt of weight 320 is at T. It's at A. Tom of weight 540 is at B, and Harry of weight W is at C. Find W. So here we said that we need to first come here and take the formula. The sum of the clockwise moment is equals to the sum of anticlockwise moment. So we have sum of clockwise moment equals to sum of anticlockwise moment. which simply